Imagine the wonder of light-as-air materials that could withstand the harsh environment of space. NASA, in its quest to perfect space travel, has been quietly working on ultra-lightweight composites and alloys, including carbon nanotubes. Developed under the leadership of scientists like Patrick Odegaard at the US Comp Center, these materials promise structures stronger than steel, yet incredibly light. NASA's ambitious endeavors don't just stop there. They're also exploring the potential of using lunar and Martian regolith, the dusty surface soils of these celestial bodies, for 3D printing structures and sensors directly on site. The innovations of Dr. Berok Kosh-Nevis and his colleagues are paving the way for building habitats and bases without needing to transport materials from Earth. When it comes to transmitting data across millions of miles from spacecraft and rovers, precision is key. NASA has refined its technology to optimize the transmission of scientific information, employing advanced compression and encryption methods to ensure data integrity. While the data doesn't travel at the speed of light, NASA's systems are evolving to manage the substantial lag, up to several hours depending on the distance, with impressive efficiency. Just as NASA remains a beacon of transparency in its scientific output, the work being done does spark the imagination. If such cutting-edge advancements are part of what is publicly shared, one can't help but ponder what transformative developments are on the horizon. As we continue to peel back the layers, we'll uncover more about the intricacies of NASA's lunar missions and the technologies crafted to reveal the mysteries on the dark side of the moon. The far side of the moon, often shrouded in mystery due to its perpetual hidden nature from Earth, has been a subject of fascination and study. NASA's Lunar Reconnaissance Orbiter, in orbit since 2009, is instrumental in capturing detailed maps of the entire lunar surface, including this enigmatic region. Equipped with state-of-the-art instruments like the Diviner Lunar Radiometer and the LROC wide-angle camera, the LRO provides invaluable data on the moon's surface temperatures and intricate topography. Though we often hear about autonomous technologies, it's important to note that these advancements are predominantly in the testing and development phases for future missions. These systems aim to enhance navigation and decision-making capabilities for rovers and spacecraft on both lunar and Martian terrains. They are more of an exciting promise for the future rather than current deployment. The far side's relative isolation from Earth offers a unique, quiet zone for future radio astronomy projects, potentially allowing for the detection of cosmic signals otherwise obscured by Earth's electromagnetic noise. This remains largely in the conceptual phase, but holds significant promise. While the LRO itself does not engage in radio astronomy, it plays a crucial role in prepping the stage for missions that might, one day, establish observatories on this ideal terrestrial body. The link between lunar missions and future Mars explorations primarily lies in the developing autonomous and robotic tech that will play vital roles across our multispectral space adventures. With each advancement, excitement builds over what technology might soon become reality. Speaking of Mars, what groundbreaking tech developments are being cooked up for the Red Planet, and how might they redefine our approach to exploration? The journey continues. Beyond NASA's headline missions lies a world brimming with innovation. NASA's Innovative Advanced Concepts, known as ENIAC, is where groundbreaking ideas for the future take root since 1998, with a focus on funding radically forward-looking concepts. These endeavors are exploratory and reside at the intersection of imagination and feasibility, a launchpad for ideas that could redefine our understanding of space. Meanwhile, at the Marshall Space Flight Center, the Advanced Concepts Office, or ACO, delves into preliminary analyses and early-stage evaluations of advanced space systems and architectures. It's crucial to recognize these programs for what they are: incubators of potential rather than immediate game-changers. The notion that NASA secretly utilizes quantum entanglement for data transfer is a stretch of the imagination. Currently, such technology is not viable within the known laws of physics. Instead, these programs take on more tangible, yet still ambitious projects that may only see fruition decades down the line. This research fuels the tank of knowledge that could one day power missions to Mars and beyond. Despite popular belief, These efforts aren't direct keys to unlocking the Red Planet, but could inspire future interplanetary mission designs, refining how we conceptualize space exploration. While NIAC operates with a modest grant funding, amounting to about $2,600,000, it's meant to kindle new ideas rather than build spacecraft. These Phase 1, 2, and 3 projects are about exploration of possibilities rather than immediate realizations, acting as a catalyst for change. In the world of space technology, whispers of the next frontier often spark debate and curiosity. What other secrets and innovative leaps may yet redefine our cosmic journey? Join us as we uncover what's in store for Mars exploration, a landscape where imagination meets possibility in unprecedented ways. Imagine a helicopter soaring through the thin, dusty atmosphere of Mars. This isn't science fiction, it's real, and NASA's ingenuity has made it possible. Originally designed for just a few test flights, Ingenuity has far exceeded expectations, proving that aerial exploration on Mars is more feasible than initially anticipated. This success opens new vistas for how we study the Martian landscape from above. Meanwhile, back on Earth, NASA's Jet Propulsion Laboratory is crafting technologies to turn Martian resources into essentials for human survival. The process, known as in situ resource utilization, aims to extract oxygen from carbon dioxide in Mars's atmosphere and produce fuel on site. These innovations are still in research and prototype stages, but they mark crucial steps toward making long-term human presence on Mars achievable. Mars rovers like Curiosity and the newer Perseverance have made significant technological strides. While Curiosity blazed trails with its design, Perseverance has improved upon these innovations with more robust wheels and enhanced mobility, specifically designed to cope with the challenging Martian terrain. This continuous development reflects a decade-long progression in rover technology, with each mission building upon lessons learned from the last. While stories of hidden technologies abound, it's important to differentiate between science-driven advancements and speculative fiction. NASA's work remains transparent and focused on empowering our exploratory capabilities through tested engineering. These developments might sound extraordinary, but they are grounded in open research and collaboration within the scientific community. Perseverance's journey, fueled by Ingenuity's airborne triumphs, serves as a testament to human creativity and resilience. As we push the boundaries of what's possible on Mars, we're connecting the dots between present missions and a future where the Red Planet could support human explorers. What lays ahead is not shrouded in mystery, but in continued innovation and exploration. What might we uncover next in this ongoing saga of human ingenuity? Stay with us as we delve deeper into how these advancements could shape not just exploration, but the very way we understand space itself. Venturing into space, astronauts are equipped with cutting-edge suits, marvels of engineering that shield them from the harsh space environment. These suits incorporate advanced real-time carbon dioxide scrubbing systems and sophisticated oxygen regulators, ensuring that astronauts receive exactly the right levels of these critical gases. While not completely autonomous from ground control, these systems provide vital support as astronauts explore beyond Earth's comfort zone. These suits also offer innovative thermal regulation. Equipped with active temperature control systems, they help maintain astronaut comfort despite the vast temperature swings encountered in space. While the idea of semi-automated real-time diagnostics might stretch reality, astronauts do rely on sophisticated onboard health monitoring that provides continuous updates on vital signs, using sensors embedded within the suit. The management of waste in space, while not containing hidden technologies, is quietly efficient. The suits incorporate practical solutions to handle waste during spacewalks, ensuring that astronauts can carry out their duties with minimal interruption. Advanced materials in the suit's design enhance their durability, offering protection against micrometeorites and radiation, a testament to human ingenuity in using technology to counter the relentless hostility of space. Communication back to Earth relies on robust protocols and backup systems, expertly developed to ensure connectivity. While these methods aren't shrouded in secrecy, they employ highly reliable protocols and occasionally utilize optical systems, ensuring that missions remain on track even amidst challenges. Though much of what evokes imagination around NASA's secretive endeavors may not reside in hidden tech, the open knowledge and active development reveal stories of minds dedicated to pushing boundaries. Looking at these advancements, one wonders not what is hidden, but what further innovations await as we push further into the cosmic frontier, which guides us to the tools designed for peering deep into our universe, those used to explore distant worlds and those secrets they hold just beyond our reach. Exploring the fringes of space has never been more thrilling than with the James Webb Space Telescope. Unlike the Hubble, JWST doesn't just continue its legacy, it boldly expands the horizon, utilizing infrared technology to peer deeper into the universe. This pioneering capability allows it to not only glimpse, but deeply analyze the atmospheres of distant exoplanets, a monumental leap achieved in 2022 Godu when it commenced its scientific mission. Mapping the atmospheres of these planets involves more than just direct observation. JWST employs sophisticated spectroscopic techniques, deciphering the secrets of distant worlds by examining the light passing through their gases. This method enriches our knowledge, comparable to having a magnifying glass on faraway orbits, where previously we merely identified candidates through indirect means like transits and gravitational wobbles. While whispers of clandestine technologies circulate, the true marvel lies in what is already disclosed. NASA harnesses cutting-edge AI and machine learning to process an ocean of cosmic data, spotting unusual signals amidst the vast starscape. These systems do more than automate. They revolutionize the search, allowing scientists to uncover details quickly and with precision, thereby leading to profound discoveries. As we journey from the cosmos to planetary surfaces, the notion of stealth takes a new form. Advanced stealth rover technology, designed to operate undetected, becomes crucial on celestial bodies where observation without interference provides a strategic advantage. This covert essence aids not only in veiled mobility, but also in ensuring that potential alien ecosystems remain unperturbed. With JWST paving a luminous path through distant star systems and new discoveries beckoning, we find ourselves at the cusp of an epoch where knowledge meets mystery, and technology propels us into the next great chapter of space exploration. Now, imagine the cosmic odyssey ahead as we embrace the potential of unseen realms, each step shadowed yet illumined by innovation, at both a planetary and interstellar scale. When it comes to exploring the surfaces of distant planets, NASA's rovers are at the cutting edge of innovation. These machines are marvels of engineering, designed not for stealth, but for resilience and efficiency. Picture this: a rover traversing the rugged Martian landscape, its wheels engineered to withstand sharp rocks and uneven terrain without sacrificing reliability. These robust designs ensure longevity and maximize the scientific return of each mission. Far from employing stealth technology, NASA focuses on the rover's capability to gather data through an array of sophisticated instruments. For instance, the Perseverance rover is equipped with a comprehensive suite of sensors that analyze soil samples and search for signs of ancient microbial life, utilizing laser-induced breakdown spectroscopy to reveal the elemental composition of rocks and soil. Energy efficiency also plays a crucial role in the rover's operation. The power generated by a multi-mission radioisotope thermoelectric generator allows the rover to maintain functionality even during dust storms that obscure sunlight. This design choice outperforms solar panels in terms of durability and reliability, enabling year-round exploration. Communication with Earth is another technological feat, highlighting NASA's prowess. Using radio waves and relay satellites orbiting Mars, data is transmitted back to Earth with remarkable clarity, allowing scientists to constantly examine findings from millions of miles away. While futuristic advances, such as laser communications, are being developed, they coexist with proven methods to ensure a steady flow of information. As we look beyond the hardware, the real intrigue lies in mission planning and the establishment of guidelines under planetary protection protocols. These procedures ensure that Earth's bacteria do not contaminate the environments of Mars and beyond, preserving the integrity of our research. Unraveling the mysteries of Mars is a complex task, heavily reliant on a foundation of available technology rather than hidden methods. Join us next as we explore how the breakthroughs in communication shape our interaction with the cosmos, opening windows to the unknown like never before. In the vast expanse of space, communication is not just crucial, it's the lifeline that connects us to our distant explorers. At the heart of this network is NASA's Deep Space Network, a trio of strategic communication hubs situated in California, Spain, and Australia. This highly coordinated formation ensures continuous contact with interplanetary spacecraft, performing not just communication tasks, but also advancing radio science through activities like radar astronomy and very long baseline interferometry. The advancements in high-frequency radio systems have significantly improved communication reliability, exemplified by the K-band systems used with the Juno mission. These strides have enhanced the bandwidth and stability necessary to keep communication channels with our spacecraft clear and efficient, powering the journey of probes as they sail through the solar system. Another exciting leap is laser communication, a burgeoning field with NASA leading the charge. The Lunar Laser Communication Demonstration in 2013 marked a historic first, achieving data transmission speeds that outstrip conventional radio methods by 10 to 100 times. Following this, the Psyche mission in 2023 is pioneering the Deep Space Optical Communications Project, setting the stage for transformative communication capabilities. While the narrative may suggest mysterious classified technologies, what truly propels NASA's efforts forward is the collaborative evolution of existing methodologies, striving for autonomy and real-time data management in spacecraft operations. The DSN remains indispensable, seamlessly integrating new optical advancements to broaden its horizons rather than replace its existing framework. As NASA continues to explode the boundaries of communication technology, it's clear that each advancement doesn't just connect spacecraft, but extends the reach of human presence further into the cosmos than ever before. This ongoing journey isn't just about the technology itself, but the new realms of discovery it opens. Each message sent across billions of miles telling stories of exploration and shedding light on the shadowy expanse of space. What new revelations will these technologies uncover as we deepen our cosmic exploration? Only time and relentless innovation will tell. Imagine bending the fabric of space and time to traverse vast cosmic distances almost instantaneously. This concept, known as the warp drive, finds its roots in the intricate equations of Einstein's general theory of relativity. In 1994, Mexican physicist Miguel Alcubierre proposed the mathematics for this revolutionary idea. His metric describes how a bubble of space-time could be compressed at the front and expanded at the back, effectively allowing a spacecraft to ride this wave without violating the local speed of light. However, the creation of such a warp bubble presents its own challenges. It would require exotic matter, an elusive substance with negative energy density that's yet to be observed, critical to maintaining the warp field. This type of matter introduces profound questions about its existence and potential harnessing for practical use. Equally fascinating is the idea of antimatter propulsion. Antimatter's interaction with matter produces immense energy, turning mass into pure energy per Einstein's famous equation, E equals mc squared. While antimatter promises unmatched efficiency, the immense cost and complexity of producing and storing antimatter in sufficient quantities currently limit its application to purely theoretical realms. Fusion propulsion stands as a halfway point, still a research subject, but more within our technological reach. Utilizing nuclear fusion, these engines could drive plasma at high velocities, enhancing spacecraft speed significantly compared to traditional methods. Although promising, fusion-based propulsion demands significant breakthroughs in physics and engineering before it can be fully realized. While these propulsion methods reside in theoretical or experimental stages, they provide a glimpse of a future where cosmic journeys beyond our current capabilities could become routine. This blend of whispers from the speculative, supported by burgeoning technological advances, keeps the scientific world abuzz with anticipation. As we continue exploring these frontiers, robotics and artificial intelligence offer dynamic synergies, pushing the boundary of what's conceivable in space navigation. These cutting-edge developments present a vivid canvas for the future of our ventures into the universe. In the ever-evolving realm of space exploration, AI and robotics are poised to reshape how we venture into the stars. Picture Perseverance on Mars. It deftly navigates through treacherous terrain, using its Aegis system for autonomous target selection to boost science returns. While it makes key decisions autonomously, the intricate analysis and mission planning are orchestrated by the bright minds back on Earth. The rover impressively handles navigation and obstacle avoidance a majority of the time, underscoring NASA's strides in robotic autonomy. On the International Space Station, the Astro-B robots float with purpose, shouldering routine tasks like inspections and inventory management, thus granting astronauts more time for scientific pursuits. Their presence is a testament to the seamless teamwork between humans and machines, enhancing life aboard the station. Venturing further into the reaches of space, the Deep Space Atomic Clock emerges as a breakthrough. This project, spearheaded by NASA, promises to revolutionize spacecraft navigation. By providing onboard precision timing, it aims to enhance autonomy, reducing reliance on Earth for guidance. This innovation holds the potential to redefine how we navigate the vast cosmic sea. The dreams of establishing a human foothold on the Moon or Mars are fueled by innovative research in AI-driven 3D printing. Companies like Gitai explore the use of local resources to autonomously construct habitats, paving the way for sustainable extraterrestrial living environments, a crucial leap toward colonization. As we look toward future explorations, the intriguing notion of artificial astronauts and advancements in artificial general intelligence linger on the horizon. While these concepts captivate our imaginations, they remain in the realm of research and projection, pointing to a future where robotics could play ever greater roles in unraveling the mysteries of space. AI and robotics integration into space missions beckons a future ripe with potential, echoing promises of impending cosmic revelations as innovation persists. Each stride forward signifies not only technological mastery, but whispers of what will come when human ingenuity and robotic precision meld. The journey continues as we explore these evolving technologies and contemplate their profound impact on our cosmic voyage. In the mesmerizing journey of space exploration, the horizon brims with innovation that promises to bring interstellar fantasies closer to reality. However, it's essential to navigate this narrative with accurate facts and realistic timelines. Promising technologies like nuclear thermal propulsion are on the anvil and could revolutionize space travel, potentially slashing transit times to Mars. Yet, these remain in the research and development stages, with practical applications anticipated not before the later years of the 2020s or the 2030s. SpaceX, with its reusable rocket technology, and Blue Origin, in its quest for sustainable space access, spearhead notable advancements that are marking significant shifts in how we view space travel. Moreover, satellite mega-constellations, such as Starlink and OneWeb, are actively bridging digital divides on Earth, showcasing tangible impacts from space technology. Artificial intelligence developed for space missions, like autonomous navigation and data analysis systems, holds the promise of enhancing terrestrial applications. However, the direct transition of these advancements into everyday industries is still an encouraging, albeit futuristic, outlook rather than a current widespread reality. Exploration-driven technologies, like in-situ resource utilization, imagined for planetary bases, carry transformative potential for sustainability on Earth, though they remain largely experimental for now. Our focus expands with time, with each pursuit fostering sustainable practices in anticipation of broader application. Educational enthusiasm fueled by such advancements is indeed tangible. The oar steered by milestones in space exploration ignites curiosity and nurtures scientific pursuits among aspiring minds, driving the next wave of explorers and innovators. Thus, while the immediate horizons may not yet feature star-bound logistics, incremental developments steer us ever closer. As we embrace each scientific leap, we're reminded of the boundless possibilities awaiting us. contemplating not just space, but the profound transformations in our quotidian existence. These narratives encourage patience and anticipation, inviting us to bear witness to the extraordinary stories still unfolding beyond the stars.